In this case, the acceleration of the tennis ball should be proportional to the force from the hairdryer in the same direction. Here we have a position versus time graph. Note that the slope of this graph gives us the velocity of the tennis ball. The nature of the curve indicates that the velocity of the tennis ball is not constant in this situation. Next, we have a velocity versus time graph. Note that the slope of this graph yields the acceleration of the tennis ball. In this situation, the nature of the curve indicates that acceleration is constant. Using the information from these graphs, we can calculate the acceleration using this equation. Next, we will look at a ball that has slightly more mass. Again, the position versus time graph's curve illustrates that velocity is steadily increasing. In contrast, the nearly linear line in the velocity versus time graph illustrates the constant acceleration. Once again, we can calculate acceleration using this equation. To prove that the force from the hairdryer was constant in both cases, we can use the mathematical expression of Newton's second law to solve for the force. One thing that we learned was that when the mass is increased, the acceleration is decreased. This proves that mass and acceleration are inversely proportional, as Newton's second law states. We also learned that force and acceleration are proportional. The force was shown to be constant in both situations through calculations, and the acceleration was shown to be constant by interpreting the linear line of the velocity versus time graph. It is important to note that this does not mean that the force is equal to acceleration, as you can see numerically above. Also, that velocity or speed is not proportional to force. For more information, please visit the kinematics playlist.